Hi, Mr. Troha. This is my reassessment for ESTM.7, which is on mechanical advantage. Yes, that's what I'm looking for, and efficiency. So, I took the liberty of writing my general equations on the paper already. Yay! So, and I also wrote down the equation for work because that's necessary to solve. So I gave myself a little situation over here. I kind of modeled it after ones in my packet, just because I actually solved all those, and so I didn't want to use one of those from the packet. So I made up my own numbers. They're just very similar, so I'm hoping it will work out. So, I'm going to solve for mechanical advantage first. I'm going to start with finding out my force my force out. Yeah, force out. yeah, force out. And so my force out is equal to the mass times 9.81, and the mass of my bowling ball, which is my situation over here. I guess I should elaborate on that. My person has a lever, and they're raising a bowling ball which weighs 10 kilograms. They're raising it 4 meters off the ground, and they're putting in 200 newtons of force. So, awesome. And so, anyway, back to my equation. My mass is 10, because that's how much I decided my bowling ball weighs. And I'm going to multiply it by gravity, and that's going to give me 98.1 newtons. Awesome. So, and actually this one's pretty easy to begin with, just because it's a relatively simple calculation, because you have mechanical advantage with your force out over your force in, which I gave myself in my problem, because most problems that you give us that much in it. So, when calculating, let me just plug that in real quick. 0.1. Yeah. So, mechanical advantage of this particular lever is 0.4905, or with sig figs, it's actually 0.49. Awesome. So that's the first half. Let's get my paper up. The second half is efficiency. Sorry, it's really hard to see. So efficiency is a little bit harder. So you have to solve for work, and that requires a slightly different equation. So work is equal to force times change in position. We're solving for work, and so the force put in is 200. No, just kidding. That's the force in. That's the work in, so that actually comes in later. The force here is actually what I solved for with mechanical advantage, so that's going to be 98.1, because it's my force of gravity, and that's the force that I'm talking about here. And I raise it 4 meters, that's what we decided. So, I'm going to multiply that real quick. 98.1 times 4, which is 392.4. And then I'm going to divide it to finish out my equation. So that's my workout. I have to divide it by work in, which is, my work in is 200, but I'm multiplying it by the distance that I moved it, which is 4, so that becomes 800. And let me just calculate that real quick. 392.4 divided by 800 gives me a work of 0.4905. And so as a decimal, work is 0.49, and then as a percent, I guess this is not work. I should say this is really efficiency. Yeah. So my percent efficiency is 49%. Yeah. So not a super efficient machine, but I guess it does the job. Awesome. So I'm hoping that will cover it for that one. Awesome. Thank you so much.